All right, so we are going to be converting our standard form quadratic into one that is in vertex form. So first we just want to write down what vertex form is, and that would be your y equals a times x minus h squared plus k. So that's our goal here. Notice this has a perfect square in it. So thinking back to what we did 2 weeks ago with completing the square to write the equation of a circle, we want to use that similar to that, but that exact same strategy of completing the square to get a perfect square trinomial. So notice there is a coefficient of a. That is actually going to be the same coefficient of a that you'd have in standard form. And then you have this k lingering off on the end. So our main goal is to get this bit here, and the k will come as I do that. So the first thing I want to do is I want to look at solely the first two terms, because that's where my completing the square comes from if you think back to the completing the square for the circle. So if I look at 2x squared minus 8x, I'm going to take out this 2 because that's my a value, which I know I need out on the front for vertex form. So if I take out 2, I end up with 2 times x squared minus 4x. And if you remember from completing the square, I want to leave a blank here so I can think about what the rest of it is going to be. Now, a little bit different from completing the square when we have the circle, I'm just going to leave some extra space and then add the plus 1 out here. So far all I've done is I've factored out the 2, and I've put the 1 way off on the end, and I have a bunch of space here in order to do my completing of the square. So when you complete the square, you're looking at this middle term here, the -4. And I divide that -4 by 2, and I get -2. And if I square that, I get 4. So now if I'm adding 4 to that, I also want to think when I add 4, I want to subtract 4 as well. So in the past, you've added 4 to this side and added 4 to the other side. However, we are going to try and keep everything on one side, because notice in vertex form, you have y equals and then everything on the other side. So instead of adding 4 to both sides, I'm going to add 4 and subtract 4 from the same side. So essentially these cross each other off, but it allows me to rewrite the equation. So now in here, this here is my perfect square trinomial. X squared minus 4x plus 4. Now that is equal to x minus 2 squared. So it's equal to x minus 2 squared. That -4 off on the end doesn't really do anything to that, so I just have -4. And then this 2 didn't change, and neither did the plus 1. Now I'm doing this because notice this -4 is trapped inside of the parentheses that the 2 is attached to. So technically this is not just -4, it's actually -8. So when you think about that, since I have changed this into a perfect square trinomial and rewritten it as x minus 2 squared, now I have this nice x minus h squared. I want to take this out, and I want to address the 2. These are 2 terms, x minus 2 squared and -4. Those are 2 terms in the parentheses. So if I distribute this, this becomes 2 times x minus 2 squared minus 8 And then again, I have plus 1 off on the end. Notice this 1's kind of along for the ride. Now I can combine these terms since they're both outside of the parentheses. And I finally have 2 times x minus 2 squared minus 7. And there is my vertex form. Notice I have the a value of 2. X minus h is x minus 2 squared plus k. My k just happens to be negative in this example. So this is in vertex form.